Hello students, how are you all? I hope you all are absolutely fine. I am your science teacher Rekha Davar. Today we are going to cover the topic of class 10, that is chapter number 1, chemical reaction and equation. What is chemical reaction? In our day-to-day life you must be observing so many changes are going on in your surrounding. What are these changes? You must be aware about it, or if you are not aware, I am going to give you some idea which you can observe that changes are going in your surrounding. In our home only, no need to go out. These all changes you can observe in your home. Number 1, suppose your mom is preparing food. So when she is preparing food, you can observe the changes when she is preparing food. Whatever recipe is preparing, she is using some raw material. The raw material are reacting each other, they are making this new product. So this one is also kind of change, or it's a kind of reaction. Number 2, where you must have observed, suppose your parents or your grandparents are doing puja, so they are using incense sticks. So incense sticks are अगरबत्ती, और जो वो sticks burn करते हैं, so they give you some fragrance. What are this change? It is also a reaction. When you are burning the stick, all of a sudden light has gone and you are not having, your emergency light is also not charged. So in that condition you are burning candles. So when you are burning candles, you must have observed some changes are there. These all are changes and which you can observe in your home only. The changes which we can see in our surrounding and which changes can be reversible, these are called फिजिकल चेंजेस, जो वापस बदल के अपने ओरिजिनल फॉर्म में आ सकते हैं. लाइक आई एम गिविंग यू एन एग्जांपल ऑफ रिवर्सिबल चेंजेस आर मेल्टिंग ऑफ आइस, evaporation. So melting of ice is what? When we are putting the water in the freezer up to a certain level of freezing point, the water changes its state and it comes in the solid form. Again, when you are taking out the ice cube or ice and when you are keeping it at the room temperature, again it is going to change it in the form that is water. So this change is going on. Water is changing into solid form, that is ice. Again solid form of ice is water is changing into liquid form of water. This is also reversible change. It can be possible. Next, evaporation. When evaporation takes place, it is changes. How come? Evaporation, vapors are gaseous form, and when it melts or it condenses, we can say, again it is coming back. That one is known as, that one is also one of the change, that is reversible change. So we can say जो change reverse हो जाए, again coming back in the previous form, that one is known as physical change. Now so many chemical changes are also there. I am going to give you an idea about chemical changes. In chemical changes, the reactants are not coming back in the previous form. I am giving you example like mama is making curd at home. So what she is doing, she is used for making curd, she is using milk. So milk is changing its chemical properties and it is changing into curd. Now curd, you cannot change it back to the form of milk. Second, I am giving you an example, that is rusting of iron. Once iron is rusted, you cannot change it back to the normal form of iron. Why? We can prevent the rusting process, we can prevent the iron from rusting process, but once iron has rusted, we cannot change it back to the normal iron. Coming on next, this process is going on in your body only, that is digestion of food. This is also a kind of chemical change. Why? In chemical changes, so many chemical properties are changing. These are chemical changes and these are irreversible. वापस लौट के नहीं उसी फॉर्म में आने वाला है. Got it? So these I have explained you about physical and chemical properties. A chemical change is always accompanied by some chemical reactions, and we always represent this chemical reaction by some symbolic formula. This symbolic formula, when they are reacting each other, that could be ion, that could be molecules, that could be atoms. So when they are reacting each other, they are known as reactant, and when they are giving you the final product, that one is known as product. Now I am giving you few example. Now symbolic representation, how can I say? When methane is added to oxygen on heating or at normal sunlight's presence, it changes into carbon dioxide, that is gas, and water, that is in liquid form. So when we are writing methane is reacting with oxygen, so here methane and oxygen both are reactant. And when I am going to write this in statement form, writing the spelling form, this one is known as word equation in which we are using non-symbolic language. But when we are going to change this symbolic language, like here I have written methane, the formula for the methane is CH4. When it is reacting with oxygen, the symbolic formula of oxygen is O2, and on reaction the product we are getting, that is carbon dioxide and water. So formula for carbon dioxide is CO2 and for water it is H2O. So we have changed the word equation into symbolic form. This one is known as chemical equation. Whenever chemical equation is occurring, in that we need at least two molecules or two atoms or two ions or two substances. When they are reacting each other, they are giving you new substance, that one is known as product. Here we can say methane and oxygen, they both are reactants, and the product we got, that is carbon dioxide and water. Now when chemical reaction takes place, what are the changes we can observe? We can observe the changes on the basis of first, state can change, the reactant, whatever reactant you have taken, so it could be solid or liquid, and again as a product you are getting, it could be liquid and gas also. So whenever your reaction is taking place, so the form of the state of reactant could not be same as the state of product. Number two, the color changes. Whatever reactant you have taken and the product you are getting, might be possible the color can change. With the color only you can recognize the product. Number three, that is change in temperature. The reactants are having their own temperature maintenance, and when product you are getting, it could be different. Or when reaction is going on, the reactants are there when you are adding two substances, so they need something external, like to increase the temperature or to decrease the temperature. So this one is, and the product you will get may not be important that you will get the same temperature product also. The variation of temperature you can observe. Next one I am going to tell you, that one is evolution of gases. Whenever two reactants are reacting each other and the product we will get, so the product will get that either we are going to this as gas only, gas is evolving, or the formation of gas is there, that one is known as evolution of gas. Next one is formation of precipitation, the bubbling process, that one is known as formation of precipitation. So on the basis of these five components or identification, you can find out that which kind of chemical reaction took place. Coming on next one, when we are writing any chemical equation, it is important to balance the equation. See, when I am going to take two substances, the reactant substance, when they are reacting and in the product, I should get the same in proportion. The first one, I am giving you an example of sodium is reacting with water. So on left hand side, my reactants are sodium and water. As a product I am getting, that is NaOH, that is sodium hydroxide, and here hydrogen is evolving. As a product I am getting NaOH and H2. Now am I getting same number of ions or molecules, or the product they are in equal number? So first of all, it is important to balance the chemical reaction in chemical equation. So whatever number of molecules we are having in reactant, that should be equal to the molecules we are getting in the product. Now first of all, what are the rules to balance the equation? The number one, we are writing the equation. Number two, when we are balancing the equation, it is very important that first we make bracket around the reactant and product we are getting. Number two, we are going to write number of molecule we have received or we have added in the reactant and we have received as a product. The number of molecules should be same on the reactant side and for the product side. Reactant means left hand side, product means right hand side. Now we are going to write left hand side molecules also and right hand side molecules also. The substance I have added, that is sodium. So on left hand side I am having here one molecule of sodium, so I have written one molecule. But right hand side, just observe, here also I am getting only one molecule. So here one molecule, here one molecule, so they both are same. Coming on next one is hydrogen. Here I am having hydrogen 2, but here on right hand side, that is in product, here I am having 2 and 1. 2 plus 1, that is 3. So hydrogen I am having 3 molecules. Now coming on next, that the third one is oxygen. Here oxygen I am having 1 molecule. Here also as a product I am having oxygen as 1 molecule. But is it a balanced equation? No. Why? Because hydrogen molecules are not equal. So to make the hydrogen molecules equal, we are balancing the equation. How to do this I am going to explain you. First I am going to multiply whatever water molecules I am having, I am going to multiply that by 2. So in that condition I will get 2 hydrogen molecules. So I am writing it here that 2 hydrogen molecules. When I am writing 2 hydrogen molecules, so in that condition write hand, what about my here oxygen 2 on left hand side, but here oxygen I am having only 1. So can I write 2 in front of NaOH? So I have written that 2 NaOH. In that condition, now my 2 molecules of oxygen on left hand side, 2 molecule on right hand side as a product. But here my Na is 2 molecules, but in reactant I am having 1. So can I write 2 here? Now I am having 2 Na on left hand side, 2 Na on right hand side. Now my equation is balanced. How I am going to check? I am giving you an idea. Here left hand side I am having 2 Na molecules. Here right hand side again I am having 2 Na, means Na is balanced, so I made it right on Na. Coming on next, here H2, just observe H2 and 2, 2 2s are 4, means here I am having 4 hydrogen molecules. On right hand side 2 H molecules and 2H, so 2 plus 2, that is 4. So in that condition H molecules are also balanced. Now coming on O molecules, left hand side O molecules or oxygen is 2, right hand side again I am having 2, so my oxygen is also balanced. So every time always remember, whenever you are going to write the symbolic equation or symbolic chemical reaction, so in that condition it is very important to check it is balanced or it is not balanced. If it is balanced, then it's good, no need to bother. But if it is not balanced, then it is your duty to check it is not balanced, and you have to, first step you have to check balance the equation. Now we are going to learn next types of chemical reactions. Now continuing to the topic, we are going to learn about types of chemical reaction. Majorly there are 5 types of chemical reaction. Number 1, combination reaction. Number 2, decomposition reaction. Number 3, exothermic reaction. Number 4, endothermic reaction. Number 5, that is redox reaction. Now today first topic is, that is combination reaction. Combination reaction in which we are using either 2 elements or 2 substances, or we are taking any single substance also, single substance to single substance, single element to single element, compound to compound, they are reacting. I am giving you some ideas. First we are taking the example of hydrogen, oxygen. They both are reactant, and after reaction they are giving you water. Now as I told you, the identification of any chemical reaction on the basis of 5 things, like as I told you, changing in state, temperature, formation of PPTs, that is precipitation. So these, on the basis of these 5 characteristics, we are going to analyze all the reactions also. Here you can observe that H2, that is in the form of gas, oxygen is also gas, and the product we are getting, that is also, that is liquid, that is water. So when gas is reacting with gas, both are in the state of gaseous form, but we are getting the product that is in liquid form. So here state is also changing. This is the example for here changing of state. Number 2, here carbon is in the form of solid, that is in place what we are going to take, carbon component what we are going to take, that is coal. So coal is in the solid form when it is reacting with oxygen, and oxygen, as you know, it is gaseous form. When it is reacting with oxygen, you will get carbon dioxide gas. So carbon is in the form of solid, oxygen is in gaseous form. The product we will get, that is also gas, that is CO2. Next, Fe means iron, that is in the solid form, reacting with sulfur, that is also in solid form, and on reaction we are getting, that is iron sulfide, that is also solid form. So here we are getting the same state, all are solid. Now coming on the second one, here we are taking ammonia gas, that is in the form of ammonia, that is in gaseous form. HCl, that is also gaseous form. So both the gases are reacting each other, and we are getting, that is ammonium chloride, that is in solid form. Coming on next one is CaO, that is calcium oxide, when it is reacting with carbon dioxide, that is in the gaseous form, and the product you will get, that is calcium carbonate. Coming on the last example, that one is carbon monoxide, that is gas. When it is reacting with oxygen gas, the product we will get, that is carbon dioxide, that is also gas. Next example, SO2 in gaseous form, when it is reacting with oxygen on catalyzing reaction, we will get, that is SO3, that is also a gaseous form. Next one is P4O6, that is in gaseous form, and it is reacting with oxygen, it is also a gas form, and the product we are getting, that is P4O10. Here one thing I have to mention, that whenever phosphorus is reacting, it always on reaction, it can explode, it can give explosion, or explosion may occur during the reaction. Coming on the second one, that is decomposition. Decomposition means when a substance is breaking down and after reacting or after reaction it gives you more than two products. Here CaCO3, that is calcium carbonate, and its name is limestone also. When it is on heating, it gives you CaO, that is calcium oxide, and the other name of calcium oxide is quicklime also. And other than that you will get carbon dioxide. Here calcium carbonate is in the form of solid, here calcium oxide is in the form of solid, and gas you will get. So here components are of two, they are made by two, that is calcium carbonate. When it is breaking you will get calcium oxide and carbon dioxide. Next one is, here I am going to give you an example of lead nitrate. When it is reacting in the presence of heat, it gives you PbO, that is lead oxide, again, and nitrogen oxide, oxygen. Here you can observe the change in color. The PbNO3 is colorless solution or mixture. On heating you will get the product. The product is PbO, NO2 and O2. PbO, you will get the color of PbO will be yellow, NO2 will be brown colored. So here color you can observe the changes in the color also. Coming on next one, before coming to the next exothermic and endothermic reaction, I am going to tell you that you can observe, I made a partition here. Here you can see that single substance are reacting and we are getting compound as a product. Here also carbon, oxygen, single are there, and I am getting, that is carbon dioxide. Next one is iron is single and sulfur is also single, but compound I am getting, that is iron sulfide. In second part you can observe, here single element or single substance is reacting with single. In second one you can observe that compound is adding to second compound, means two compounds are reactants, and as a product we are getting, that one is also a compound, a single compound with many combination of many compounds. Next one CaO, CO2, that is also, both are compounds. The getting product is also compound. Coming on next, here CO is compound but oxygen is element. So you are getting different example. Here element or single substance is adding to single substance. Here compound is adding to compound. Here compound is adding to again single, and you will get the different one. So again I am coming to the next topic, that is exothermic reaction. Next I am going to explain you about exothermic reaction. Exothermic reactions are that reactions in which heat is evolved or heat comes out. Methane is reacting with oxygen, so we are getting carbon dioxide. The same reaction we have seen in previous video, or in the same video at previous time, carbon dioxide, water, but we are getting heat also at the end product. Second, magnesium ribbon, when it is reacting with oxygen, it is giving you magnesium oxide as well as heat. This we have learned about exothermic reaction in which heat is evolved. The example of exothermic reaction is respiration. In respiration we are going to give out heat during this. It is also a chemical reaction, we can say. Coming on second, that is endothermic. In endothermic, sunlight is needed for reaction. Here heat is coming out as a product. Here heat is needed for the reaction. I am giving you an example of photosynthesis reaction. Carbon dioxide is reacting with water. We needed carbon dioxide and water for photosynthesis. In presence of sunlight and chlorophyll, the product we get, that is glucose C6H12O6, that is the food of the plant, plus oxygen and water. Here we can say heat is absorbed. From where we got the heat? We got the heat from sunlight. Plant is getting heat from the sunlight. That is the natural source of heat. An example, as I told you, the endothermic reaction example is photosynthesis. Coming on displacement reaction. Displacement reaction is the reaction in which a single element used to react with a compound and it breaks the compound. The weaker one is going to separate and the stronger one is coming with the element only. I am giving you by some example. Here zinc is reacting with copper sulfate. Here in copper sulfate, copper is weaker and sulfate is stronger. So it is going to break down and zinc is going to combine with sulfate. So here we will get on reaction we will get zinc sulfate, and zinc sulfate as well as we will get copper. Now you can observe the variation in colors. As I told you, the 5 identifications are there to observe the chemical reaction. Here zinc is of gray color and copper sulfate is of blue color. After reaction, the product we are getting, that is zinc sulfate, it is colorless, and copper, that is of brown color. These reaction I have explained you about displacement reaction. Now coming on redox reaction. Redox reaction is combination of oxidation reaction and reduction reaction. What is oxidation? In oxidation, the oxygen gets released or gain, and hydrogen is loses or it loses its ion. Next one, the electron as always loses. Coming on next, that reduction reaction. In reduction reaction, oxygen is loses and hydrogen is gain and electron also gain. So now I am giving you example of oxidation reaction or redox reaction is when copper oxide is reacting with hydrogen, then you on heating you will get copper as well as water. Here copper oxide on reduction it will give you copper, but here hydrogen on oxidation you will get water. So this one is the example of redox reaction in which both the reactions are going on. Now next I am going to tell you about the effect of reaction. That one, which reaction? Redox reaction. The effect of redox reaction is number 1, corrosion takes place, and number 2 is rancidity. So I covered all the first topic, all the important component of the topic in this video. I hope you must have understood. I'll get back to you in my new video. Till then, all of you, bye.